Hey everybody, it's Mr. Bliss. This video is the first in a series of videos to introduce some concepts in biology. This is macromolecules and polymers. So, macromolecules. Macromolecules have a number of names. Let's first look at this one, macromolecule. What does the name tell us? Well, macro as a prefix means large, so we know that these are going to be large molecules. These are often also known as biological molecules. So we know that they're going to be important for building cells. And we also know that these are often referred to as organic molecules. These names all pretty much mean the same thing, but the names tell us different things. First, that word organic tells us that we are going to see carbon. We're going to see carbon and hydrogen and oxygen and phosphorus and sulfur. These are the elements that are most abundant in living things. They make up 97% of all living things. And those are going to come together to make living structures. So we're going to see them make organelles, and those are going to form cells. And they're going to be large, fairly large, compared to the types of molecules that we've been looking at so far, like water and hydrogen gas. So, macromolecules and polymers. Let's look at that word polymer. Well, a polymer is a structure that is pretty much defined by the fact that it's repeating subunits. So this is a polymer. And each one of these smaller units here, like that, is going to be known as a monomer. Mono meaning one, so one unit. Poly meaning many, so many units together. So how do these two things come together? Well, there are going to be four types of macromolecules or organic molecules that we're going to talk about. And those four are the following. The first type that we're going to be talking about are carbohydrates. The second is lipids. The third is proteins. And the fourth are nucleic acids. And I'm going to end up making a series of videos on these because I think that each one of these types of macromolecules deserves its own video, its own treatment and explanation. So, what do macromolecules and polymers have in common? Every single one of these types of macromolecules exists as both a monomer form and as a polymer form. So just to start us off, what we're going to do is look at a monomer form of a carbohydrate and a polymer form of a carbohydrate. We'll review these more in a future video about carbohydrates, but if we have the monomer form of a carbohydrate, it looks a little bit like this. Just make it really basic. It's a ring structure, and each of these places where there's a corner or a vertex, these are carbon atoms, and our carbon atoms are going to be connected to a hydrogen and a hydroxide group. Just like that. And I'll put this one up here. Obviously, these are going to be three-dimensional shapes, but the way that I have to draw them here, they're two-dimensional, and that's okay. And if we have another one, yeah, I should finish this, but CH2OH. You do not need to know this structure, but just to look at it, if we have, oh, that's ugly. If we have another one here, like this, and these have the same functional groups on the end. Let's look at how a series of monomers join together into a polymer. We have a process that is known as dehydration synthesis that is going to be used to connect monomers together. All types of monomers, whether it's a carbohydrate monomer or a lipid or a protein or a nucleic acid. Here we have some examples of carbohydrates. I'm just using them as examples. So, dehydration synthesis. I'm sure you've seen this word dehydration before if you don't have enough water, specifically if you're losing water. That's what dehydration means here. And synthesis means to make. And if you have something that is synthetic, it's man-made. If you have photosynthesis, you're making sugars from light, photosynthesis. So here, you're going to be losing water to make a larger structure. So if we look at our monomers here, our carbohydrate monomers, what you'll see is, I should have drawn this a little bit different, specifically because here we're going to have the oxygen connected here and the hydrogen here. But if you look at them from a different perspective, okay, this hydrogen here and this hydroxyl group here together form H2O. And if these molecules came together and we lost this section, well, this oxygen here is going to want to bond with something, and it's going to end up bonding with the carbon on the adjacent molecule. So let's get rid of these here like that, and we'll draw in the bond that will form, just like this. And again, water will leave. Well, in this process, you're linking two monomers together, and we're building a larger structure. We're building a polymer from our monomers. This is what's going to happen to build a polymer from each one of these types of macromolecules. The inverse of this is going to be known as hydrolysis or hydrolysis. And again, we see this prefix hydro refers to water, and lysis, specifically in regard to biology, means to break. So what are we doing? We're using water to break a molecule. Here, we're going to see the opposite. We're going to start with a polymer, and we're going to end with monomers. So here, it's literally the inverse of the above drawing. So we're just going to use that same drawing. Okay? If I were to reverse this arrow here and add water to a polymer, well, what's going to happen is this bond is going to break, and the water is going to split apart, and we're going to have a hydrogen over here, and then a hydroxyl over here, and we're splitting our polymer into its smaller monomers. So here our polymer splitting into smaller monomers. So in this video, the important words here are, let's start from the top. We should know what a macromolecule is. A macromolecule is also known as a biological molecule or an organic molecule, and they're important for life. All of them have a small subunit known as a monomer and a larger structure known as a polymer made from several monomers connected together. Here are our 4 types of macromolecules that we'll make future videos about independently. And these are our 2 processes. This one is for making larger polymers from monomers, dehydration, synthesis. Focus on that word, synthesis. And this structure here, or this process here, hydrolysis, is for breaking a polymer into smaller monomers. I hope that's helpful. If you have any questions, leave some comments, and I'll do my best to answer them below. Thanks.